Yo, what's going on, guys? Welcome back. Today I'm doing the HTTP Request Smuggling v1.3. This was a request on the Discord again, so once again, if you guys want to see certain videos or specific videos, either go on the Discord, check out the Patreon. I recommend it. I do a video separately on the Patreon every week that's not usually Tryhackme, it's usually something else. If you want to support the channel or help out in any way, that's the best way to do it, because that's also where I sell my Linux course and some other things. So let's go ahead and get started. This was a request, again, from a Discord user, so this is taking a little bit of a break from the SOC Level 1 path, because we want to help the Discord users as well, so they kind of get priority, and then the Patreon gets priority over that. So if you guys are wanting to see specific things, that's where you're going to see it, or that's how you get access to me. So the introduction. So basically, what is HTTP request smuggling? So if you don't know HTTP, and this graphic doesn't make a lot of sense. And the other thing I don't like about it too much is they kind of put the cart before the horse at the very beginning. They're trying to show you it, and I understand that, but the graphic doesn't explain it very well, and the description doesn't explain it very well. But what they're doing here, essentially, is you can see there's the front-end server and the back-end server. Well, the front-end server, right, is reading this, and it reads it as one request, because it's saying, oh, we're looking for the transfer encoding to validate. We're not looking for the length, okay? So that's fine. So it thinks this whole thing is one request. Okay, cool. The back-end server, so meaning now you're past the front-end server, so you've quote-unquote authenticated, right? There's maybe not authentication, but you're accessing the back-end server now, right? The back-end server is actually looking at it as two requests, because it's looking for content length, right? You notice there is no transfer encoding down here, so it's using just content length. So if you look, content length, it's thinking, okay, well, these are two different requests. So you're bypassing the front end server with this malicious request, right? And then you're accessing internal resources with this request. And you notice it comes in as two requests is what they're showing, and they're saying, hey, 200 error, okay, this is good. That's what they're saying. This is good. So how we do that, right? Now, one thing they say here is it's crucial to consider the presence of return and new line characters, right? This is true, right? It's crucial to make sure you're aware of that, because they will read separately. Now, another thing, again, you guys know I don't read this to you, so if you want to read it, read it. But another thing that they talk about in here is, if I can find it, is right here. Note that testing for request smuggling can potentially break a website in many ways. This is why you don't see that much HTTP request smuggling in pen tests. You will typically see like, hey, we think this is possible. Do you want us to test it? Or it might just be a finding on here that like, hey, how does your backend and your front end server expect packets, because we can just tell you if it's going to be probably vulnerable. The reason you don't see done very often is it can break things a lot, right? Because right here, if they get fully desynced, if these pipelines don't work together anymore, right? If your backend database or your backend server no longer is operating with your front end, that's a problem, right? So it's not very common you see these in pen tests. Typically it's more of a like, we think this can happen. Are you sure you want us to do this? Here's the risk, because it can break, and it is a pretty big deal. So just know that. So prerequisites, we need basic understanding of HTTP 1.1 protocol and its headers, and they give you those boxes, right? So let's go ahead and look at modern infrastructure. Okay, so components of the modern web apps. So these are modern web apps, right? Front end server. This is usually the reverse proxy or load balancer, right? So typically, this is how you prevent DDoS attacks and things like that, is you have a front end server, a proxy, load balancer, whatever, that it's kind of like if you have an application, right? Well, you can't just have it on one server, because if you do, you're going to be able to get 30, 40 people maybe with modern computing, maybe 50, 60 people on there, right, at one time. And then if it goes past that, you broke it, right? So how does something like Amazon work? Well, Amazon couldn't do that because they're getting thousands and millions of people on there all the time. So what do? Is they have a proxy and a load balancer that's going to take those requests and go, hey, server 1 over here is only handling 10 people, throw them on there. Server 2's got, it's loaded, it's got 60 people, whatever, and they just balance that load, right? So that's what that front end server is. That's the first one you're hitting, right? The back end server, this is the server side component that processes the actual requests, right? It interacts with the databases, it serves the data to the front end, so it's actually what you're looking at, that type of stuff, right? Then you have the databases, which the databases are where the actual information stored, right? So the user accounts, the sales, whatever you're doing. Then you have the APIs. This allows the front end and the back end to communicate and integrate with other services. So how do they communicate? They usually have requests, which are just APIs. Excuse me. Then you have microservices. Instead of a single monolithic back end, sorry, getting a drink. Many modern applications use microservices, which are small independent servers that communicate over a network, often using blah, blah. Okay, cool. So now how do we look at it? Well, here's how it looks. You have your user, they make a request, the request hits that load balancer, and then you notice there's 3 servers in this case. It will put you on whichever one has the least load on it at the time, and then that server, whatever request you make, whatever you do, it will go to the backend resources and say, hey, let me get this information, right? So some of these requests, right, if you did like for HTTP smuggling, right? If you did a request to something specific, the load balancer and the reverse proxy might be looking for people trying to access that and say, no, we're not giving you access to that, right? So those are things we can bypass using this. So now, role of caching mechanisms. This is important because this is what you could mess up quite a bit if you get these out of sync, right? So content caching. So if you don't know, what sites do typically is they cache things that don't change very often, and that's because if they cache them, then the server and the website and everything doesn't have to work very hard because it's already sitting there waiting for you, right? So content caching by storing web content that doesn't change, right? Caching mechanisms can reduce load on the web servers, speeding up delivery. Database queries. So this is if you do frequent queries. So like, let's say every time you click submit, it submits a query, right? That query is probably cached, so it doesn't have to rebuild the query every single time. Full page. So sometimes an entire web page can be cached, so they don't need to be regenerated every time for each user, right? That's really nice for high traffic sites. Now, edge caching, content delivery networks cache content closer to the user at the edge of the network, right? So it's so that you don't have to just sit there and go all the way through the network to get all that data. Again, it's cached towards the edge. Then API, caching the responses can significantly reduce the backend processing. Okay, perfect. So what sits in front of one or more web servers and forwards clients' requests? That is a reverse proxy. Okay. Now, behind the scenes, this is what it's going to look like, right? So this is important that we have to actually understand the HTTP request structure. If you don't understand this, you're not going to be able to do this, right? And one thing I want to make out very clearly is, again, be cautious doing stuff like this, because one thing I see a lot with new hackers is they want to test all this stuff out. Well, that's great, but certain things are dangerous to do on live machines. It just is. It's kind of like some Metasploit modules will tell you that there's a chance they will blue screen that machine, right? Would I want to try that? Even if someone was like, hey, this is a, good pen test, blah, blah, whatever. I'm not even going to do that on a pen test, because if I go to pen test something and I crash your machines, what good is the pen test? What did I prove? That I can crash your machine? Cool. Thank you. Now I have to get an admin to do this, stand it back up. We're losing revenue as this machine sits down, right? So it's not worth it. I can go, hey, this could crash your machine. Yeah, I can do it if you want me to, but you need to fix the issue, not let me just crash this machine and then tell you why, right? So, okay, so every HTTP request comprises of 2 parts, right? Here you have the header and the body. Here's the header, here's the body, right? And it's funny, they say 2 parts and then they list 3. But you have the request line, which this is what you're actually requesting, right? So this is the post request is, you're doing a post request and you're trying to, in this case, they're looking at the admin login page. Well, then they're using HTTP 1.1, okay? Then you have the actual header here, which is the metadata of the information, right? You have your content length, your content type, what your user agent is, which is usually your browser, and then transfer encoding, what it is chunked. So here, That's the metadata, the message body. This is what you're actually submitting. So in this case, we're saying, hey, our username is attacker and the password is password, right? And so that's the actual body of the request. Now, the content length header. This is one of the reasons this is exploitable, I guess, if you will, right? Is if a server is looking for content length, right? If you add this up, that's 14 bytes, right? So cool, we add that up. That's great. Well, if they're looking for the content length, I can put something there, right? If the content length matches up, perfect. But if the back end server is not looking for content length, if it's looking for the actual transfer encoding method, because that's two different methods, right? Then the content length won't matter. So on the second request, I can put whatever content length I want because they're not looking for it, which means, guess what? I can put whatever I want there because the content length, all that tells it is when to go on to the next packet, right? It's telling it, hey, this packet that I'm sending you only has 14 bytes. Once those 14 bytes are up, that's a different request. That's something else, right? Well, the backend server doesn't know that because it's not doing content length. So the backend server is looking for the chunks, right? So it's reading it as all one. So in that case, I can send this, and the second piece down here, the body, would actually just be another request. And then the first piece, the first server goes, okay, I'm looking for content length, got the content length, cool, move it along. The second one goes, oh, this is two separate requests because it doesn't care about content length. It's going to, once it hits that chunk, whatever chunk you're telling it, it's going to go, the next piece is a new request. So that's how we can get multiple requests in there. That's why it's called HTTP smuggling, because you're smuggling a second request in there. And then once it hits the backend server, or that second server, right? Not the backend, I'm sorry, but that second server, it's going to say, this is two requests. Well, what does that mean? That means the first request, or the second request, the hidden one, right? No, there's no checks and balances on that first server. So now here's the transfer encoding header. So you can see that's the differences right there. The content length is what it's looking for. Now this is, you see chunked in all of the stuff we're doing here, but it can be compressed, deflate, and gzip as well. Just multiple different ways or different things it can be depending on the type of encoding, right? So you see chunked here, right? B is equivalent to 11 in decimal, so that's a hexadecimal, right? Specifies the size of the chunk of what's going to come, right? The chunk, blah, blah, is the data. That's the same data as the one up before, right? Followed by a new line. The request is terminated with a 0 line, right? Indicating the end of the message body. Each chunk size is given in hexadecimal form. So this is the expected chunk size, right? And then the end of it is right here. So what we're saying is that's how they're expecting how long that packet will be. Well, if they're looking for two different methods, we can bypass it, right? That's what we're looking for, is if they're looking for two different methods. And this happens a decent amount, right? So now, how do the headers actually request or affect the request processing? Well, here's how, right? This is because they determine how to parse the requested body and influence caching behaviors. So this is why you got to be careful, because what we talked about, right? If the request is, they're seeing it all the time, right? There's one request they're seeing all the time. Well, what do you think they're going to do? They're going to cache that data, right? Well, cool. If you cache it, if I'm doing this attack and I'm sending all these requests and I'm caching extra data, I'm messing up your actual website. I'm actually screwing with what your website's actually caching, where your website should be caching the important information that should be displayed. I'm messing that up. I'm fucking with it, right? So that's why this can mess up websites. So I'm going to keep emphasizing that. So manipulating headers like content length and transfer coding can create vulnerabilities. For instance, if a proxy server gets confused, which because you'll see we're sending 1,000 requests, not 5 requests, right? It might not properly distinguish where one request ends and another starts. And that's where we can get through and say, hey, you don't know where one request is because you're seeing this, so you're caching it and you're just pushing it through. Now I can actually smuggle in extra requests, right? This is the origin. Okay, front end server, back end server, interpret HTTP request boundaries. For example, if both content length and transfer encoding headers are present, if they're both there, then there can be ambiguities, because there can be, what if one of them is looking for one and the other's looking for the other? They can be messed up. Or what if one's looking for one, but the content length doesn't match up? It's going to go to transfer encoding, so we can get one to go through, and then the second request, the content length won't match, so it'll be looking for that chunk, right? Some components prioritize content length, while others prioritize transfer encoding. So if that, like I said, if one at the beginning of the request prioritizes one and the other one, that's pretty obvious. So it's actually a pretty simple attack, you'll see. But so here, the attacker sends crafted request with both the headers, so both headers, the content length and their transfer encoding, and you can see when it sends it to the front end, right? Here's one, this all one big packet. Well, the front end says, hey, we checked the content length, it matches what's expected, push it into the back end. The back end says, hey, we're looking for transfer encoding. This is 2 chunks, not one. So it means it's 2 requests, right? Because it's going to get to that first chunk and it's going to go, that must be the end of that request, go to the next. So it sees 2 different requests here. You bypass this front end, and then what's it do? Sends the response, right? It processes it just like normal and it sends the response. So now we're actually able to send additional requests. So what request header indicates that request or response body size in bytes. This informs the receiving server how much data to expect. That would be content length. If I can type. Okay. Now, here is, so you'll notice there's really only 3 types, right? There's, if you see, there's, I guess even 2, but there's content length and transfer encoding, and then transfer encoding and content length, meaning which one's first, right? Is it, which one is the first server looking at, which one's the second? So here's the request smuggling for that, right? We just showed this, not going to do it to show you the same thing, but here's how it looks. So to exploit this, an attacker crafts a request that includes both headers, ensuring that the front end and back end servers interpret the request boundaries differently. So what does that mean? It means I'm going to put them both in there. I'm going to put content length and transfer encoding. Why? Because the chance of the first server, if it's looking for content length, it's there. If the second server is looking for transfer encoding, it's there. So if you just put them both, there you go. And then you can see the first one, we're on this search page, right? The second one, we're actually trying to update. So we're sending the update page something, right? Well, if we were trying to go to the update page over here, it would probably be like, no, you don't have permission to do that. Or it would probably say like, excuse me, you know, whatever. Maybe that proxy says, don't let people go to this. Well, if we know that update page exists, once it gets past that proxy and that load balancer, right, it's going to separate this, and this is going to be a separate request. Another nice thing about this is nothing looks malicious, right? If you have that proxy actually logging or anything like that. Now, you could find it because the request is there, but nothing looks malicious. So your security tools and things like that are going to go, okay, this is a legit request, right? Now, you could still get some security tools that can definitely look at this, but just keep in mind that this is a way to bypass some of that. And then you can see down here, the second request, there's only one content length, right? And that's because the second request is going to be processed by that second server. You're not trying to bypass anything. You don't need them both. Okay, so incorrect content length. So when creating a request smuggling payload, if the content length is not equal to the actual length of the content, several problems might arise, right? First, the server might process only the portion of the request that matches the content length, so that they're going to show an example of that. So here, you can see the body is username equals test and query equals test, right? And what this does is it actually presents a, this, whatever, when you go to submissions, it actually shows what you've submitted, right? So this would be what's being put in the database. And you can see it says name test, query test, because that's what they put. But if you mess up the content length, right, because here you can see the content length is 24 characters, or 24 bytes, excuse me, right? That's, if you add that up, that's correct, right? Now, if you change that content length to 10, well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That will be all it reads. So now when you go to check it, look at that. The only thing it reads is T, right? Because it only is reading 10 bytes of content and then saying that's the end of that packet. Let's move on to something else, right? So let's do, I'm just copying this for the, so content length, transfer encoding. All right. Now the chunk or the transfer encoding technique is basically the exact same thing in reverse, right? Because it's just saying that transfer encoding is the first server and the second server is content length. So that's why you see the exact same process. The only difference is they changed this wording up here. So no need for us to go through that. But you can see here, you have transfer encoding, right? And then you see it says chunked. And then here's the process or the post request down here for the same thing. The only difference is they changed which one's which, right? And then you notice the content links down here. And you notice here, the content link doesn't really matter because it's looking for this, right? They're putting them both in there to confuse it. All right, so now in the above payload, the front end server header, blah, 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 hexadecimal for 120, which if you add all that up indicates that the next 120 bytes are part of the current request process. So what does that mean? It means there's chunked. This is supposed to be the body of the request, which is true for that first server. The second server is looking for content length. Well, if you look, that content length is only 4. What does that mean? It means once it hits 4, it's going to go to the next request. Well, guess what? This is 120. So it's going to go ahead and say, this must be a whole new request, right? And content length equals 15. Well, that's 15. So it's just reading it as 2 different requests, right? So now what does this stand for? Which is kind of annoying that we have to do it again because it's literally the same thing. All right. Now, transfer encoding obfuscation, also known as transfer encoding, transfer encoding. So transfer encoding, transfer encoding. They're the same thing. They're not looking for content length, right? So this is the third one. So the TE.TE technique arises when both the front end and the back end servers use transfer encoding. Okay, so that's what it's looking for. In transfer encoding techniques, the attacker takes advantage of the server's inconsistencies of handling the transfer encoding present. Okay, so here, we're not going to show you, or they're not showing you anything different. They're just showing you the attacker sends the request with both of them transfer encoding. Well, the first one goes ahead and returns response for the initial part of the request, process first transfer encoding, then they process the second, send the response, right? So once again, the exact same workflow. The only difference is they're both getting transfer encoding. So this is what it looks like. So example, okay, so here's what it looks like. Transfer encoding chunked 1. Well, okay, so what that means is in the above payload, the front end server encounters 2 transfer encoding headers. Boom, boom, right? Well, the first one, that's chunked. That's their standard thing. But the second one, chunked 1, is non-standard. So depending on the server's configuration, the front end server might request, might process the request based on the first one, which is chunked. So it'll say, move it along, this is good. And ignore that chunked 1, right? And interpreting the entire request up to the 0, boom, as a single message. So there you go, one whole chunk, right? The backend server, however, might handle that this chunked 1 is different. It can either reject the malformed part and process the request similarly, which means just take that first one and send it on, or request it differently. If it processes only the first 4 bytes based on that content length, as indicated by the remaining part of the request starts from post update, is then treated as a new request. So what they're trying to do is get the second server, even though it's looking for transfer encoding, to go, this is weird, I don't know what this is, let's revert to content length, right? That's what you're trying to do. You're trying to send it malformed packets to say, let's try to get this to actually go off content length, because then it will separate them. Keep in mind, a lot of this is hit and miss, right? Like it's based on the way the server's set up, and there's no way for you to know that unless you try or ask, right? So typically on a pen test, this is better to figure out the configurations with the admin or whatever and just say, hey, this could happen. I'm not going to do this unless you really want me to, but this could happen, right? Okay, so now they actually give us a walkthrough, which is one of the first boxes I've seen that they do it this way. So interesting. So we're on the Tryhackme attack box here. We're going to go to the website. Maybe. Okay, so the vulnerable environment, Apache traffic server, right, is the front end proxy. Nginx is the web server backend, and PHP processes the content. Due to differences in how blah, 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 content link and transfer, there's a potential for HTTP request smuggling. Start by adding HTTP to your Etsy host. Okay, so first thing we got to do is add this to the Etsy host. Okay, so you can see the IP is, oh, they actually added it in there. Okay, so we'll say leave this here for now, and we'll go to Etsy host. And we see the host, so we'll say gedit hosts. Gedit's not on here. Okay. What is the, is it Sublime? Okay, so we'll just open it with Sublime. Don't want to do that. Okay, so we'll open the file, and we'll just say Etsy hosts. Hosts. Okay, I double clicked it. There we go. Okay. Now all we'll do is we'll just take this one, paste that, and then the IP is 10.10.199.140. All right, should be good to go. Save it. All right. There we go. Now we should be able to go to this website, copy link address. All right, and we're in. So now we have this development portal where this website's under development. We can suggest something to the developers. Cool. So now we need to open Burp Suite, looks like. It should be under web, Burp Suite. All right, and we're going to open Burp Suite. We're going to capture this packet, and this is going to be kind of our de facto packet for the rest of the attack, right? So you can see we're going to open Burp Suite. We just want the root GET request. Pretty simple request. I don't know that we need to actually even enter anything. Using Burp Suite, intercept a request sent to the website's index. Okay, so it doesn't look like we need to actually enter anything, which is nice. Okay, start burp. So we'll go, if we can get it to load here, go here. This machine is going very slow. I'm not sure why. There we go. So we've got burp on. Okay. So now we'll go to proxy, intercept is on, and we'll just refresh this bad boy. And then we go over to burp. And you can see here is the GET request, and they're saying that's the one we should be looking at. So if we go to HTTP history, there you go. There you go. All right. So pretty self-explanatory, pretty simple. Everything's the same. The only difference is the cookie's different, but that's no big deal. Okay, so now we just need to take the request and forward it over to Intruder. Now we've got the request over Intruder. Okay, so now copy and paste the below payload. So this is our actual payload, right? There's two requests. This would be after enumeration, right? Because we've already figured out that there's a contact page. So we want to mess with that contact page, right? So all we're going to do is we're going to copy this and we're going to put it into the payload position. So you see if we go over to intruder, payload, here's our payload position, right? So we're going to say position. Okay, go to the payloads tab. Okay, so we go to position, and here's what we're actually trying to do. So you can see they put that request in there. This is the initial request. It doesn't really matter what the initial request is. They're just using that as a packet. I don't actually know why they put that in there, because you could have just made a request with the same thing, but that's fine. So here we go. The target is HTTP Request Smuggling. Perfect. Now the payloads, you can see we're going to set null payloads, right? So if you go to payloads, we're going to say null payloads, and you can see it says generate. Well, look at how many they're generating. 10,000. So generate 10, 1, 2, 3,000 payloads, right? So we have 10,000 payloads. So if you remember, we're trying to mess with the caches to get them enough entries in there for it to cache it and let us through, right? So you can see now we go to the resource pool, and we're trying to say, hey, okay, how many? We're basically just maximizing what we can do. So maximize concurrent requests. You don't have to keep this the exact same, but this is what we're going to do. So create new resource pool, maximize concurrent requests. Here they're saying 10. I don't know if this box can handle 10 the way it's going. Delay between requests with random variations, 2,000 milliseconds. So this could take some time, but we'll see. Okay, so then we just click start, and no, I don't want to restart. Okay, so there we go. So now we've got everything. We should have everything set up. We start the attack, and we should see it happen. Okay, thank you. What does that say? Some attacks are time throttled. Okay, it should still run. All right, of course we run into this, right? So let's see. You may follow the screenshot below for the settings. Well, I tried, and it says I can't. So generate 10,000. You'd think they would allow you to do this, but I guess not. Maybe it's the. Maybe I have to have the auto throttle on. I don't know. Some functionality is disabled and attacks are time throttled, which is fine. Why can't I still run it? It's not. I'm not understanding. Why can't I run it? Okay. Well, let's see if we can figure this out. Okay. It would be one thing if they would just tell me what the request is or what the issue is. I get that it's timed out or something. Maybe it's too many. Let's just continue indefinitely for now, because what we'll do is you just need so many, right? Is it actually running when I'm doing this? It's just saying that the whole time? That's my question. Is it actually running, and every time when I click OK, I'm stopping it? Doesn't look like it's running. Okay, so now it's running. So maybe it was just because I had 10,000 in there, because it's saying it's going to be whatever you want to call it, time gated, right? Okay, so and then you'll see if it works. I don't know why they're time gating it that hard, but they only had 40 requests before it worked, right? And what they did is, or they say whatever, but after a few minutes, check submissions website to see if the request to contact PHP is smuggled, containing the request of other users. Meaning, if you look at the request they actually submitted, right, they're trying to get the contact PHP page, right? But if you notice, they're putting this username, test, and query, whatever. That's the actual payload. So what that means is that should put that in the contact page, theoretically. Okay, so it is working. It's just taking forever, which is interesting, right? So what we're going to do is we're going to go back to the browser. We're going to turn off burp because we don't want to capture our request. Then we're going to say go to, what is it, contact.php. So, oh, it's under submissions, excuse me. So we're going to say submissions. I think it was just submissions. Nope, just submissions, right? And we should see submissions here if there is none. So here's here's the submission that I just did, right? And if we go to burp, you can see 471. That's probably ours, right? So if we go, if we go to submissions, we click on it, your query has been saved. Okay, so that's good. Now we just have to keep, well, I didn't want to refresh that. I wanted to, nope. There we go. So see how it's still doing submissions? That's because that process is going through, right? Well, there's our request. Okay, and you can see it's going to keep going through, right? They're still doing it. So what's happening is the actual request that I'm doing is getting submitted here. And you can see it's submitting every time I do it, it's submitting a new one. So that's what's happening now, which I don't want to keep submitting a new one. And then I lost it. Okay. And then let's make sure this is actually still running. Okay, it's still running. We'll just go through and see if it actually, okay, username is test and query. So we did the query, but there's no information. So unfortunately, you just have to wait. And this is very slow because the free edition is time gated, which they keep telling us. I get it. Okay, and you can see here's all the requests. It's going to keep coming. There's 4, and that, like it says, it even tells you here, accessing the application while smuggling is taking place will capture your request instead of the request from the target user, meaning you're just going to keep getting requests over and over, which is fair, right? So go through the text files to check for the password that was appended. So we're looking for that appended password. Now keep in mind, every time you refresh it, you're just going to keep adding more submissions, which is what it's doing for me. So I want to wait a little bit. So I'll probably cut it and come right back to when we get it, because I'm not going to make you guys sit through this pain of sitting here. So I'll be right back. Okay, welcome back. So it did take some time. You can see I'm impatient. This is me refreshing and then checking the logs, but it did take some time and I did get it. So I'll show you guys here. You can see it's still running the requests. It took about 20 for me. Might take some different for you, but basically what this is doing is you can see it's running through, and down here they're saying, hey, username is test and query, right? So, and the rest is blank. So what's happening is this is going past the first one, right? Which the host is HTTP Request Smuggling.THDIM, and then it's going through, everything's fine, and it's just doing a post request on the website. Well, once it gets through, it's now doing a post request onto the contact page, right? And it's looking for our username, and we left the password blank, right? Well, what we can check here is in our nice little thing, you can see the username is test, the query was get login, and they automatically appended the password for us. So that's really nice. We didn't have to do anything. They appended it for us. So there's your password. Now, does this always give you a password? No, not always. If that's what you take away from this, please don't. Go back and review. You're just viewing stuff that you maybe shouldn't be able to view at times. It's not always a password, so just know that. So now we've got the page. We should be able to go to the website, which is this. All right, and now we got to log in, and we have our password. They even have an account name. And there you go. Tryhackme, I can smuggle. Now we go over here. There you go. It's that simple, guys. This one may confuse you if you're not very familiar with HTTP and how servers work, but
make sure you go through and look. Really, the big thing here is look at the workflows of like this and understand what's happening. It's very simple. It's the attacker is using transfer encoding or content length, depending on which one first, right? Or the transfer encoding twice, but using it. And then the second server is actually doing the other, or it can do transfer encoding as well. And they're just tricking it, right? And the reason they're sending 10,000 requests in this case, granted, it only took 40, but the reason they're sending so many packets in this case is because they're trying to mess with the caches, right? They're trying to get it to slip through, and when it does, it will actually just get to that second server. The second server says, hey, this is 2 requests, boom, and it processes both of them. So if the first server, you can't submit certain requests, you can maybe smuggle them in and get them to the backend server, and that's the goal. So let me know what you guys think, if you guys like this box or not, and let me know. Again, check out the Patreon Discord if you guys want to be able to talk to me, request stuff, ask questions, all that jazz. So thanks, guys. Have a good one.